Good evening, ma'am.
Good evening, sir. You can start now, sir.
Okay, ma'am.
Good evening, sir.
Yeah, then good evening. So last class we were learning about the preparation of alcohols. So various method we learned the preparation. That is from the mechanism also we learned. From alkenes we learned. By acid catalyzed hydration we learned. This mechanism I taught you. So you should remember this mechanism. It's a 3-mark question for your board exam. And hydroboration, oxidation reaction, also I taught you in detail. And from carbonyl compounds, reduction, this also I taught you. So lithium aluminum hydride is a very good reducing agent. Anything which undergoes oxidation will be called as a reducing agent, or anything which gives nascent hydrogen. Nascent hydrogen means hydrogen in atomic state will be called as nascent hydrogen. So any molecule which gives nascent hydrogen will be called as a reducing agent. Lithium aluminum hydride is a very good reducing agent. Sodium boron hydride is a good reducing agent. Likewise, sodium in ethanol is also a good reducing agent. So it is wrongly marked here. It is wrongly marked here. All right. So I wrote it like this. Aldehyde is represented as RCH double bond O. When this aldehyde is reduced using lithium aluminum hydride or other reducing agents, so what happens is one hydrogen attacks oxygen, the other hydrogen attacks this carbon. So what we get is you get RCH, you get OH here, and the second hydrogen which attacks here forms. So this is nothing but primary alcohol. This is primary alcohol. R can be anything. When I say anything, it can be an alkyl group or it can be an aryl group. It can be a benzene ring or it can be methyl, ethyl groups. So aldehydes on reduction with lithium aluminum hydride, primary alcohols are formed. So this is a wrong representation, the double bond. All right. Now, similarly, when we talk about ketone, this is right. Ketone, they've represented right. We can write ketone like this also. RR and C double bond, rearranging the terms. When this is reduced using, again, the same reducing agent, lithium aluminum hydride, one hydrogen attacks this oxygen, the other hydrogen attacks this carbon. So we get R, OH, and H. This is a secondary alcohol. This is secondary carbon atom containing OH group. Therefore, it will be called as secondary alcohol. This is from aldehydes and ketones. Now, further, we also learned in the last class the reduction with acid and its derivatives. Now, reduction of acids and their derivative, carboxylic acids. Now, when we say carboxylic acid, a carboxylic acid can be represented as RC double bond O, OH. RCOH is carboxylic acid. This is a general representation of a carboxylic acid. When this carboxylic acid is reduced using lithium aluminum hydride. See, this lithium aluminum hydride is a very good reducing agent because it can give many number of nascent hydrogen. For this reaction, we require 2 nascent hydrogen, but with carboxylic acid and its derivatives, we require 4 nascent hydrogen. So 1 mole of carboxylic acid will react with 4 moles of nascent hydrogen. This is carboxylic acid. It reacts with 4 moles of nascent hydrogen. This 4 moles of nascent hydrogen, we can write it 2H and 2H. So what happens is this 2 hydrogen and oxygen gets eliminated as water. In place of this oxygen, 2 hydrogen goes. Therefore, we get R, CH2 and OH. This is primary alcohol. So carboxylic acids on reduction with lithium aluminum hydride, we get primary alcohol. Similarly, if we take an ester, we learned this also in the last class. a repetition so that we'll have a continuity. We'll take a specific example, CH3, C double bond O, O, CH2, and CH3. This is called as ethyl ethanoate. It's called as ethyl ethanoate. The IUPAC name of this molecule is ethyl ethanoate. This ethyl ethanoate, when it is reduced using lithium aluminum hydride. So what happens? Now 4 hydrogen atoms there. The bonds break here between carbon and oxygen. One hydrogen attacks this oxygen. The second hydrogen attacks this oxygen. And the third and the fourth hydrogen attacks this carbon. So what do I have? In the first case, I have CH3, CH2, and OH. CH3, CH2, OH. The second case you can see it is CH3, CH2, and OH. So you get 2 moles of ethanol. You get 2 moles of ethanol. You followed?
Yes, sir.
Till here we have done in the last class. Now we have to learn with Grignard reagent, preparations of aldehydes from Grignard reagents. Now, when we say preparation of aldehydes with a Grignard reagent, this reaction we do not have. That is reaction with oxyrane we do not have in the syllabus, not to worry about it. But we have to learn the preparation of alcohols, primary, secondary, and tertiary from Grignard reagent. So I will take this space to explain the preparation of alcohols from Grignard reagent. It is from Grignard reagent. We will write the general reaction. The specific example you can practice at home. The first one is the reaction of the Grignard reagent with formaldehyde. Reaction of Grignard reagent with formaldehyde. Formaldehyde is represented as HCH double bond O. HCHO is called as formaldehyde. This formaldehyde, when we react with Grignard reagent, RMgX. Now, magnesium is a metal, it's highly electropositive. Therefore, what happens? It donates electrons. So magnesium gains positive charge and this carbon gain will negative charge. It undergoes heterolytic cleavage. Likewise, the pi bond breaks and this pi electron will shift on oxygen. Oxygen will gain negative charge and this carbon will gain positive charge. So far, did you understand? Do you understand this?
Yes, sir.
So now what happens? Oxygen is negative. Therefore, magnesium and X will attack oxygen. And here this carbon is positive. Therefore, this R group attacks carbon. So what will I have? What will I get? I will get an intermediate compound. That is HCH. You have, now this pi bond is broken already. So you get OMgX and you have what? R2. This is an intermediate compound. This intermediate compound, when you hydrolyze in the presence of an acid. So hydrolysis, we can write H and OH, H plus and OH minus. So again, magnesium is metal. So therefore, magnesium will have positive character, oxygen will have negative character. So what happens? This hydrogen will attack oxygen and this OH will attack magnesium. So what we will have? H, CH, R, and you'll have what? OH, plus you will get a byproduct, Mg, OH, and X. Magnesium hydroxy halide, Mg, OH, and X. This is the byproduct. This is written as R, CH2, OH. We can write this as RCH2OH. This is nothing but primary alcohol. Nothing but what? Primary alcohol. So whenever a formaldehyde, methanol, METHANAL, methanol is the IUPAC name. METHANAL. When methanol is reacted with Grignard reagent, an intermediate compound which is formed, this on hydrolysis gives what alcohol? Primary alcohol. Did you understand this mechanism? Preparation of alcohols from Grignard reagent. Did you follow this?
Yes, sir.
Now I want you to answer me the question. Now this is methanol. instead of using methanol, we will take a specific example. I will take CH3 here. This is ethanol. Now this is ethanol. Now when ethanol is allowed to react with Grignard reagent, in place of this hydrogen, I have taken what? CH3. Everything remains the same. The reaction remains the same. You get CH3. Followed by hydrolysis, you get CH3. So you can see here, and CH you have. So how can I write this? I can write this as CH3, not like this. Now let this be same. What type of carbon atom is this? What type of carbon atom is this?
The secondary.
So what
carbon.
alcohol is this? So you will get what?
Secondary
Alcohol. So when ethanol is treated with a Grignard reagent, an intermediate compound is formed, followed by hydrolysis, you get secondary alcohol. So I'm going a little faster. Now this hydrogen also, we replace it by CH3 group. If we replace it by CH3 group, so what happens? Here also you will have CH3 group. Here also you will have CH3 group. This becomes what carbon atom?
Tertiary.
So what alcohol you will get?
Tertiary alcohol.
So see, formaldehyde, methanol when we use, you get primary alcohol. Acetaldehyde when we use, you get secondary alcohol, that is ethanol. This is called as an acetone. It is ketone. This is ketone. So we can write this molecule for our understanding, CH3, C double bond O, and CH. This is ketone. This is nothing but what? Acetone. It's a ketone. When ketones are treated with Grignard reagent, an intermediate compound is formed, followed by hydrolysis, you get what? Tertiary alcohol. Now, instead of R here, to be more specific, if I take an alkyl group here, I'll take an alkyl group here, like CH3. Here also I take CH3. So what happens? This R becomes what? CH3. And this R also becomes what? CH3. So what's that I'm getting? Tertiary butyl alcohol. So it's a tertiary alcohol. Did you understand this? Now,
Yes, sir.
yeah, now you can see this is a complex reaction they've given. Need not have to worry about the complex reactions here. So these all are bond line formula of certain molecules. So this is reaction with ketone. I clearly taught you here reaction with ketone, the mechanism. So reaction with ketone gives you what? A tertiary alcohol. See, this is tertiary carbon atom. This is CH2. This also is CH2. All right, this is tertiary carbon atom, tertiary alcohol you will get. So I have taught you the mechanism. Don't worry about this. This looks very complex. Don't worry about this. Now the next one is fermentation. By fermentation, we know that people prepare alcohols at home. All right. Now fermentation is nothing but breaking of huge molecules into a smaller molecule by an enzyme, biochemical catalyst, known as fermentation process. All right. Now, fermentation is low decomposition of complex organic molecule into a simple compound in the presence of suitable microorganisms, which are source of biochemical catalysts known as yeasts. Now, starch is the organic polymer. It is a carbohydrate. This carbohydrate, when treated with a suitable microorganism or a biochemical catalyst, or it is treated with yeast, this starch, a big molecule, breaks down into butyl alcohol and you get acetone. So fermentation of starch, we can prepare alcohols. We also can prepare alcohols from inversion of cane sugar. Inversion of cane sugar, that is not there. Now, that's in a different topic. We will learn that later. Now, physical properties of alcohol. Lower alcohols are liquid, while higher, having more than 12 carbon atoms, are salts. Generally, we understand that alcohols are in liquid in nature, but alcohols above carbon containing carbon 12 carbon atoms, they are solid. So any alcohol for that matter, they are colorless, they are neutral substances with characteristic sweet alcoholic odor and burning taste. So raw alcohol, you cannot taste, it will burn. So alcohols are colorless, they are neutral, they have characteristic sweet alcoholic odor, and they have a burning taste. The lower alcohols readily soluble in water. Methanol, ethanol will be readily soluble in water. And the solubility decreases with increase in molecular weight. As the molecular weight increases, the solubility will decrease. Now, ethanol is the alcohol which is used to prepare alcoholic beverages. So whatever alcohol people drink, they're all made of ethanol, alcoholic beverages. Right? No other alcohol is fit to drink. Only ethanol is fit to drink. This ethanol is soluble in water. Now, the solubility of alcohol in water can be explained due to the formation of hydrogen bond between highly polarized OH group present in both alcohol and water. Alcohol, normally we represent it as ROH. Water, we can represent it as H2O like this. Now, what happens? Hydrogen and oxygen. There will be a hydrogen bond formed between hydrogen of alcohol and oxygen of water. So that is why the lower alcohols are soluble in water. However, in higher alcohols, the hydrocarbon character in alcohol, hydrocarbon character chain increases, showing steric hindrance. So as the molecular mass increases, the R group becomes bigger. When this R group becomes bigger, it shows a steric hindrance. Hence, the solubility in water decreases. All right. The first 2 points, I hope that you understood. The third point is boiling point of alcohols are much higher than those of corresponding alkenes. Meaning, if you take ethane, it is C2H6, and if you take ethanol, C2H5OH, the boiling point of ethanol will be very high compared to ethane. Or we can say the boiling point of ethane is very, very low compared to alcohol. That's what it means. Boiling point of alcohols are much higher than those of corresponding alkenes. This is due to intermolecular hydrogen bonding. This will form intermolecular hydrogen bonding. Therefore, the boiling point is high. And this you note down. Among the isomeric alcohols, primary alcohol has higher melting point and boiling point compared to secondary and tertiary. This is the fact, because the fact that secondary and tertiary alcohol, the alkyl part outweighs the OH group due to branching. Lower alcohol forms solid addition compounds with anhydrous metallic salts like calcium chloride, magnesium chloride. So lower alcohols will react with calcium chloride, magnesium chloride to form anhydrous metallic salts like CaCl2 dot 4C2H5OH, MgCl2 dot C2H5OH. These are the physical properties. Now, chemical properties. See, by analogy of water of crystallization, these alcohol molecules are referred to as alcohol of crystallization. For this reaction, alcohol cannot be dried over calcium chloride. Alcohol cannot be dried. So if moisture is there, if you have to remove moisture from alcohol, we cannot dry it using calcium chloride because calcium chloride reacts with alcohol to form crystals, addition compounds like calcium chloride and alcohol. Now, the next concept is chemical properties of alcohols. Are you following? Are you there?
Yes, sir.
Yeah. Now, chemical properties of alcohol. The first one is reaction with active metals, acidic character. Alcohols are neutral in nature, but they have partial acidic character. They are weakly acidic in nature. Alcohols are weakly acidic in nature. Why they are acidic in nature? See, alcohol are weakly acidic in nature due to which they react with group 1 alkali metals and they liberate hydrogen gas. So any molecule which gives hydrogen will be called as acid. Now, alcohol, ROH, is the general representation of an alcohol, ROH. When this is allowed to react with sodium metal, alkali metal, first group element. Sodium being more reactive, it will displace hydrogen. When say displace hydrogen, you get RONA plus hydrogen. So hydrogen cannot exist as H. Therefore, we take 2 moles of OH and 2 moles of sodium. You get 2 moles of salt, liberating what gas? Hydrogen gas, H2. Since this molecule alcohol reacts with alkali metals to give hydrogen, this proves that alcohols are very weakly acidic in nature. The order of acidity or the acidic order of alcohol is methanol is stronger, acidic, more acidic than primary. Primary is more acidic than secondary, and secondary is more acidic than tertiary alcohol. This acidic nature of alcohol is due to the presence of polar OH bond. What is that polar OH bond? Now, for an example, if you take ethanol, this is CH and OH. Hydrogen is electropositive. Therefore, this bonded pair of electrons will be pulled towards oxygen. Oxygen gains negative charge. Hydrogen gains what charge? Positive charge. This is called as polarity, or this is called as polar OH bonds in alcohols. So due to the presence of polar OH bonds, alcohols are acidic in nature. The second point is the second property. The first property is acidic nature, that acidic character we have learned. The second character, the property is esterification. Important question for a second PUC, 12th standard, and also for the competitive exams. We'll have to learn this. Now, what is this esterification? In simple words, esterification is formation of an ester. Formation of an ester is called as esterification. Esters are organic compounds which contains carbon oxygen double bond single bond O, or any molecule which contains COO as a functional group is called as an ester. Now, how do we prepare an ester? How can we prepare an ester? This ester can be prepared by the reaction of alcohol. Any alcohol we will take. The general reaction is here. We will take ethanol. This ethanol, when it is treated with carboxylic acid, carboxylic acid, again, they have represented it wrong here, carboxylic acid. So we can write a specific carboxylic acid, acetic acid, CH3 COOH, acetic acid. In the presence of concentrated sulfuric acid. This concentrated sulfuric acid is a excuse me, it's a dehydrating agent. Dehydration means removal of water. So since concentrated sulfuric acid is a dehydrating agent, it removes water. So hydrogen atom from the alcohol and OH group from the carboxylic acid, they get eliminated as H2O. When they get eliminated as H2O, what you have now? You have C2H5, you have this oxygen, you have the CO, that is C double bond O, and you have what? CH3. So molecules which contain COO as a functional group is called as esters. Is called as what? Esters. So formation of esters is called as esterification. It's an important question for 2 marks. Explain esterification, they're asked. So esterification, esters are formed by the reaction between alcohol and carboxylic acid. Any alcohol and any carboxylic acid. So we have taken ethanol and acetic acid. When ethanol and acetic acid is treated with a dehydrating agent like concentrated sulfuric acid. Dehydrating agent means a reagent or a chemical which removes water will be called as a dehydrating agent. So esters are formed. You can name this ester. IUPAC name you can write. This will be ethyl ethanoate. It will be 1, 2, root word is eth, carbon to carbon single bond, but it contains a functional group. Therefore, ethane ethanoate. So this is an ethyl group. Therefore, the IUPAC name will be ethyl ethanoate. You should know how to name the organic compounds. Next is reaction with acid derivatives. When we say reaction with acid derivatives, now for an example, if you take acetic acid, that is CH3COH. This acetic acid, if this OH is replaced by chlorine, so you get CH3COCl. This is called as acetyl chloride. It is called as what? Acetyl chloride. This acetyl chloride is an example for acid chlorides. Since it is derived from a carboxylic acid, it is called as derivatives of acid or acid derivatives. And one such example is acetyl chloride. Likewise, if you take benzoic acid, and if from benzoic acid, if OH is replaced by Cl, it's called as benzoyl chloride. This benzoyl chloride and benzoic acid, not benzoic, acetyl chloride, these are examples of acid derivatives. These are examples of acid derivatives. Now, we will have to learn a specific example. The specific example I will write here. Hello? Yes? Is anybody talking?
No, sir.
No, someone was, okay, anyway, background, okay. Now, this
Yes,
reaction will be called as acetylation. 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 That is reaction of an alcohol with acid chlorides. So what is acetylation? The reaction of alcohol with acid chlorides. Acid chlorides or acid chlorides. Acetyl derivatives. Acetyl. Kavya, please switch off the mic. Kavya, switch off the mic, turn the mic. Kavya, turn off the mic. Formation of acetyl derivatives. So alcohol reacts with acid chloride to form acetyl derivatives. We will take a simple example. We'll take methanol, and this methanol is allowed to react with acetyl chloride. Acetyl chloride is CH3COCl. We will write like this, ClCOCH3. In order to show the elimination process, we're writing. This is called as acetyl chloride. This is called as acetyl chloride. So H and Cl gets eliminated as HCl. In place of what happens? H and Cl, the carbon and gets bonded to oxygen. So you get CH3, you get O, single bond C, double bond O, and CH3. So this will be called ethanoate. And this will be called methyl ethanoate. So this is the reaction. This is called as acetylation. Formation of an ester by acetylation. That is by reaction of an alcohol with acid chlorides like acetyl chloride or benzoyl chloride is called as acetylation. Did you follow this?
yes,
You
sir.
follow this? Yes. All right. Now, reaction with isocyanate, isocyanuric acid. So this reaction is not there in our syllabus. Isocyanuric acids, all that we do not have. Anyways, now alcohol, isocyanuric acid is HN double bond C double bond O. This isocyanuric acid, when allowed to react with alcohol, we get an intermediate product, and finally we get an ester, amino ester you get. See, this is an ester group, amino ester. So reaction with ethylene oxide also is not on the syllabus, but we can see this is ozonide. Maybe if time permits, we will learn these reactions after we complete the syllabus. Now, some of the reactions here, reaction with sulfuric acid is important. Now, when I say sulfuric acid is important, this is ethanol. When ethanol is treated with excess of concentrated sulfuric acid. So ethanol we will write like the CH3, CH2, OH. The other ethanol molecule will write CH3, CH2, OH, second ethanol molecule. When this is treated with concentrated sulfuric acid, this concentrated sulfuric acid is a dehydrating agent. It removes water. Now, if this water is removed, what else is obtained? You have CH3, you have CH2, you have this oxygen, you have this CH3 and CH2 and CH3. So this is nothing but ether. Ethers are formed when alcohols are dehydrated with concentrated sulfuric acid. So alcohols are formed. The next one is action of
Sir,
acid. Yes.
sir, in reactant side, we should have two ethyl alcohol, no, sir?
No, that's what this is not mentioned here. That is why I wrote 2 molecules of ethanol here. All right.
Then only we'll get an
100%,
ether,
yes,
sir.
100%. This is called a stoichiometry. If you have,
Yes.
see, you cannot take only one molecule of ethanol. It is very difficult to isolate one molecule of any compound for that matter. We have to take in terms of moles. So 2 moles of ethanol only will give you what? 1 mole of ether. That is called a stoichiometry, what you learned it in first use. Yes. Next one is action of halogen acids. Now, these halogen acids are also called as hydrogen halides. It's also called as hydrogen halides. Halogen acids are also called as hydrogen halides. Now, hydrogen halides, HCl, HBr, it can be anything. Now, an alcohol, C2H5OH, alcohol, when it's allowed to react with hydrogen halide, generally we'll represent it as HX. It can be HCl, it can be HBr. And this is treated with anhydrous zinc chloride. This anhydrous zinc chloride is a dehydrating agent. Anhydrous zinc chloride is a dehydrating agent. Not only concentrated sulfuric acid, this is also a good dehydrating agent. All right, so when I say this is a dehydrating agent, what happens? It removes water. What is this? Water gets eliminated as a byproduct. When water gets eliminated as a byproduct, what you have? Now you have C2H5 and you have X. Now this is nothing but alkyl halides. So we can prepare alkyl halides from alcohol by treating an alcohol with hydrogen halides or halogen acids. Now you can see the reactivity of halogens is in the order. HI is more reactive to ethanol compared to HBr, and HBr is more reactive compared to HCl. All right, so we can prepare alkyl halides by also reacting it with what? Alcohol. Hydrogen halides reacted with alcohol in the presence of anhydrous zinc chloride. Dehydration takes place, forming alkyl halide. Now, for an example, if you take C2H5OH and when you allow it to react with hydrogen iodide, the presence of anhydrous zinc chloride, H and OH gets eliminated as H2O. In place of OH, I goes. So you get C2H5 and I. This is ethyl iodide. So alkyl halide. The next reaction is action of thionyl chloride. Thio means sulfur containing compounds. The formula of thionyl chloride is SOCl2. The formula of thionyl chloride is SOCl2. So an alcohol like C2H5OH, when it is treated with thionyl chloride, what happens is the bond between carbon and oxygen breaks. The bond between hydrogen and oxygen also breaks. 2 chlorine atoms there. 1 chlorine atom reacts with H to form HCl. The second chlorine atom reacts with carbon to form the product C2H5Cl. The next left out is sulfur and oxygen. Sulfur and oxygen reacts with this oxygen and sulfur dioxide gas gets eliminated. This process is called as Darson's process. DARZAN. This Darshan process happens in the presence of a catalyst pyridine. In the presence of a catalyst pyridine, pyridine. So this is the best method of preparing alkyl chlorides. We can prepare only alkyl chlorides because no other halogen is there, thionyl chloride. That's the disadvantage, but it is the best method of preparing alkyl chlorides. Best method of preparing alkyl chlorides. Why it's the best method of preparing alkyl chloride? Because sulfur dioxide and HCl both gets eliminated. Pyridine is a base. Sulfur dioxide is acidic. Hydrochloric acid is also acidic. So pyridine will eliminate both these. So you'll have only the product. Was it alkyl halide? The next reaction is action of phosphorus halides, PCl5 and PCl3, phosphorus pentachloride and phosphorus trichloride. Now we will take an example. Phosphorus halides. Phosphorus halides will react with alcohols to form corresponding alkyl halides or corresponding haloalkanes. Now for an example, if you take ethanol, C2H5OH, this ethanol, when it's heated with phosphorus pentachloride, the bond between oxygen and hydrogen breaks, the bond between carbon and oxygen breaks. One chlorine reacts with hydrogen to form HCl. The second chlorine reacts with carbon to form C2H5Cl, that is ethyl chloride. 3 more chlorine atoms are there. Those 3 chlorine atoms reacts with oxygen along with phosphorus to form phosphorus oxychloride, POCl3. Phosphoryl chloride or phosphorus oxychloride. This is alkyl halide. Similarly, this reaction can happen with phosphorus tribromide, or it can also happen with phosphorus triiodide. The reactions can happen. So in generally phosphorus halides, it can be phosphorus pentachloride or phosphorus pentabromide, or it can be phosphorus pentaiodide. This reaction will take place. The next reaction is action of ammonia. Action of ammonia. When vapors of ammonia react with alcohol, both alcohol and ammonia vapors are passed over heated alumina. A primary, secondary, and tertiary amines are formed. So when alcohol is treated, alcohol and ammonia vapors are passed over heated alumina. You get primary amine, further again reacts with alcohol to form secondary amine, and secondary amine further reacts with alcohol to form tertiary amine. So this reaction with ammonia, reaction of alcohol with ammonia is not in our syllabus, so don't worry. But remember, so alcohol when treated with ammonia, vapors of alcohol and ammonia, when it is passed over alumina, Al2O3, we get a mixture of primary, secondary, and secondary, tertiary, alkyl amines are formed. Primary, secondary, tertiary amines are formed. Now, one of the mechanisms we have to learn that hydration is removal of water. Removal of water. So alcohols undergoes dehydration to form alkenes on treating with acid. Example, concentrated sulfuric acid or concentrated phosphoric acid or catalysts such as anhydrous zinc chloride or alumina will bring about this reaction. Now, for an example, this is an alcohol. This is a primary alcohol. So we can take this as CH3. This is not primary. It is a general representation of an alcohol. We will take an example. Primary alcohol, we will take ethanol. CH3, CH2OH. This ethanol, when you treat with concentrated sulfuric acid, H2SO4, I have written it like this, HHSO4, for our convenience. So what happens is this OH and this H gets eliminated as water. So when they get eliminated as water, what is the compound formed? The compound formed is CH3, CH2, HSO4. CH3, CH2, HSO4. This is called as ethyl hydrogen sulfate. It's called as ethyl hydrogen sulfate. This ethyl hydrogen sulfate further will react with ethanol. Further will react with ethanol at 410 Kelvin. At 410 Kelvin to form diethyl ether. This hydrogen and this HSO4 gets eliminated as sulfuric acid. So you have CH3, CH2, you have O, you have CH2, and you have CH3. So this will be called as diethyl ether. So alcohols, when treated with concentrated sulfuric acid, dehydration takes place to form diethyl ether. To form diethyl ether. This is at 410 Kelvin. So at 440 Kelvin, what happens, you see? The same ethyl hydrogen sulfate, CH3CH2.HSO4. When you heat it at 440 Kelvin, what happens is, now the CH3, I am writing for my convenience as, I'm writing the CH3 for my convenience as CH2 and H. So at 440 Kelvin, what happens, you see, this hydrogen and this HSO4 gets eliminated as the byproduct H2SO4. What is left out now? What is left out now? CH2.
So CH2, CH2.
Double bond CH2. So since hydrogen and H2SO4 is removed, there will be a double bond formed between carbon and carbon. So ethene. See this condition. Reaction is same. Ethanol with concentrated sulfuric acid. In the first case, it is 410 Kelvin. At 410 Kelvin, you get ether. The same ethyl hydrogen sulfate, when it's heated at 440 Kelvin, the product what we get is ethene, alkene. Did you follow this?
Yes, sir.
Yeah. Now,
Yes, sir.
this is dehydration. We'll have to learn the mechanism. We will learn the mechanism in a few minutes' time. Now, other two reactions. This is secondary alcohol. This is secondary alcohol. The secondary alcohol, when you heat it with 85% phosphoric acid, 85% phosphoric acid at 440 Kelvin. When you heat it with 85% phosphoric acid at 440 Kelvin, what happens is, now I will write it properly here. I cannot show the reaction here. CH3, COH, H, and what? CH3. So what happens is, now this CH3, I will write for my convenience like this. I'll write it like this. I write it as CH2 and H. So I'll say this hydrogen and this OH gets eliminated as, when they get eliminated as water, what is that product formed? You have CH3, you have CH, single bond CH2. What will happen? Since we are eliminating hydrogen from this carbon, OH from this carbon, what will be formed? A double bond will be formed. So an alkene is formed when are heated at 440 Kelvin and with what? 85% phosphoric acid. This is nothing but an alkene, the same reaction I've written here. I hope you understood this.
Yes, sir.
Now the same reaction here also, tertiary alcohols. Tertiary alcohol, I will write like this: CH3, CH3, C, CH2, H, I will write OH. This is CH3. So when this is treated with 20% phosphoric acid, H3PO4, phosphoric acid. This is also H3PO4, phosphoric acid at 360 Kelvin. So what happens is 360, 358 Kelvin. What happens again? This hydrogen and this OH gets eliminated as water. When that gets eliminated as water, what you have now? I have CH3, single bond CH3, and what will be formed here? A double bond CH2. It is also an alkene, right? This is the representation, different representation I have given. I hope you followed with this.
Yes, sir.
Now I need to teach you the mechanism. I am looking out for the place. I'll teach you the mechanism of this reaction, and then we'll continue the class possibly in the next class. All right. Now this mechanism I'll teach you. Now mechanism of dehydration. Now one mechanism we learned in the beginning of the class, we learned one mechanism. That is, what's that mechanism we learned? This is acid catalyzed hydration we learned. Hydration. Now, the reverse we have to learn. This is dehydration. What we are learning is reverse of today. All right. So since I need place, all right, I'll write here. It is mechanism. This is dehydration. Dehydration. Opposite of that. Mechanism of dehydration. Now, first step. Step one is protonation of alcohol. Protonation of alcohol. So when alcohols are protonated, when alcohols are added with protons, protonation means addition of proton. When alcohols are protonated, this protons, you get it from an acid. So what we get is a compound CH3, CH2. Already you have OH. That O I will write like this. H. This H plus attacks oxygen. So therefore, this H plus will go on oxygen. So this is called as protonation of alcohol, and this ion is called as oxonium ion. It's called as oxonium ion. This is the first step. This is the first step in dehydration. So protonation of alcohol. When you protonate alcohol, you get oxonium ion. Step two. Step two is cleavage of carbon-oxygen bond. Carbon-oxygen bond yields carbocation. Cleavage means breakage. The breakage of carbon-oxygen bond gives you carbocation. That is, we have formed an oxonium ion here, CH3, CH2O plus H and H. So when this bond breaks unevenly, so what happens is you get water as a product. Both the electrons goes towards oxygen. So therefore this positive character will neutralize water. And you have now CH3 and you have CH2, and this carbon will have positive sign. Why? Because both the electrons are moving away from this carbon. This is carbocation. This is carbocation. Now, step 3 I will write here. Step 3. Elimination of proton. Elimination of proton from beta carbon. Beta carbon. Elimination of proton. What is this elimination of proton? Now, this you can write, you can see, I write it like this. CH2. The CH3 I write it as H, CH2. Single bond, CH2 plus. This is nothing but carbocation. This is what I've written here. This carbocation will undergo a loss of proton, elimination of proton. This proton gets eliminated. When this proton gets eliminated, H plus, this bond shifts here. So therefore, what you get CH2 double bond, CH2. This is nothing but what? Ethene. So in the first mechanism, we learned hydration of ethene to prepare an alcohol. Now we have started with an alcohol and we learned to prepare what? Ethene. That is called as what? Dehydration, the reverse reaction. All right. So again, here it takes place in 3 steps. One is protonation of alcohol. Alcohol is protonated by reaction with an acid. So to form an ion called as oxonium ion. This oxonium ion undergoes carbon-oxygen bond cleavage. So this cleavage to form carbocation. This carbocation, beta hydrogen is eliminated. So here the functional group was there, CH2OH. So therefore this is alpha carbon atom. Next to alpha carbon atom, it's beta carbon atom. So hydrogen is eliminated from beta carbon atom. So therefore it's called as beta elimination. So you get an alkene. Did you follow this reaction? Did you follow
Yes,
this
sir.
reaction?
Yes, sir.
Any clarification? We learned a lot today. Now we have to learn with some more chemical properties and go for phenols, all that. Possibly tomorrow we will continue. All right. Any clarification done, Lakshmi? I'll stop the class now. If you have any clarification, you can ask.
No, sir.
No. Ma'am.
Thank you, sir. Okay, sir.
Thank you, sir.
Yeah. Bye.